Hello everyone, my name is Natalie Rakowski, and I'm a student at the Georgia Institute of Technology. I'll be producing video lab reports throughout this semester. Today's topic is constant velocity, and I'll be defining constant velocity, linking it to Newtonian physics, running an experiment and testing for constant velocity, and modeling constant velocity in Python, a programming software. After comparing my experiment and computer model, I will be able to determine if my car in that time frame was going at a constant velocity. First, let's start by defining constant velocity. Velocity is a vector quantity, meaning that it has two parts. In velocity's case, these are speed and direction. Velocity is defined as the change in position over the change in time, and so it can be found by subtracting the initial position from the final position and dividing by the time that passed during the object's movement. Now, let's think about Newton's laws of motion. Newton's second law is that force is equal to mass times acceleration. If you further expand this by defining acceleration, you see that force is equal to mass times the final velocity minus the initial velocity over the change in time. If you plug the stats of an object going at constant velocity in this equation, acceleration would be 0, and 0 times mass would also give you a force of 0. This explains Newton's first law, inertia, because it states that an object in motion will stay in motion unless another force acts upon it. For my experiment, I took a video of my car going at around 10 miles per hour in cruise control, traveling in a straight line in the direction of 240 degrees southwest from north. My hypothesis is that it was traveling at constant velocity, and I will test this by mapping the car's motion in Tracker software and comparing it to a Python computer model of constant velocity. I chose to use a 1-second video clip of my car, and I oriented the origin so that my car would start at the origin and travel down the positive x-axis. If I were to have flipped the axis, it would have had no effect on my experiment's results, because I am just looking for constant velocity, though the velocities I recorded would have been negative in nature. After mapping 1 second of my car's motion in Tracker, I found the plotted data on a position versus time graph was very linear, a sign of constant velocity. I then took the average velocity of my car during that second, 4.2 meters per second, and made a computer model in Python of a point mass traveling at constant velocity at 4.2 meters per second for 1 second. Because I made the time step on the data calculation loop 0.01 seconds, it gave me 100 data points, making it a very accurate measuring tool. In conclusion, I found that my car was traveling at constant velocity for the full second. Not only is it a linear graph, but it also follows the computer model graph data exactly when they are compared on the same graph. This means that the net force of my car is 0, and that all the forces acting on it are 0. So gravity and the normal force in the positive and negative y direction both add up to 0, and also the cruise control and the motor of my car are exerting equal force against the friction on its wheels and air resistance on the exterior. Thank you for watching my video, and have a great day.